So it's all about how to bring AI and Gen AI together in order to transform the network. This is what the talk is about. And basically, I will start by, let's say, defining what I mean by AI continuum for the network operation in particular. And then I will be zooming into a kind of family of use cases. It's not one use case, but it's a family of use cases. The first one is the observability. What we mean by observability for the network, what we mean how to use Gen AI for the health check of the network, for example, on-demand status checking on your nodes, your base station, your MME, and your 5G infrastructure. So how you can do this with Gen AI. And of course, how to troubleshoot this with Gen AI, and also what to recommend so that you can have optimal field engineering, if not to go to the closed loop, which is the second family of use cases. So let's get started. The AI continuum for network, I used to start by this slide because I want to remind that Gen AI is actually AI. And when we talk about AI, we're talking about the data quality is very important. So there is no magic. Gen AI is still AI and still needs to have a very good quality of data. And the garbage in, garbage out is still valid also for Gen AI. So we need to prepare the data. We need to care about the quality. And as Laurent was mentioning, we need also to select the sources of data that we want to feed to our models. Otherwise, we will be bringing noise to the model. The third part is about security, and also Laurent touched base on that. So security is the first, let's say, feature for Gen AI. You cannot just bring your private enterprise data and then through this to whatever excellent model, and then you are going to share this to outside from your enterprise. So this is important that you have the right architecture and the right security, let's say, framework for you to use Gen AI while maintaining your privacy and of course, the compliance of your security of your enterprise. And the last part, of course, is the cost. Not each and every use case needs to be done with Gen AI. We need to select the use case that really can be solved with Gen AI and that we cannot solve with machine learning, deep learning, or even with some statistics and analytics. So this was just to remind what Gen AI is for the network and for each and every domain. Now, those are the pain points that are coming back all the time since years now about when we talk about let's go to the smarter network. Let's go to cognitive network. Let's go to autonomous network. But those are all the time coming back. First of all, it's the network itself. The network is, described by a topology that this topology includes nodes and includes edges and connection in between. And those are today not captured. The dependency, it's not captured. The topology information, it's not an accurate information today to use and to combine with your telemetry data, time series data, and, for example, the alarms, etc. The second point is that today the operation, to identify what is happening in the network, like you have degradation everywhere, you have alarm everywhere, but how to understand which one or which node is, let's say, propagating the problems to the others, or which node is the faulty node that it's impacting all your network. It is always time-consuming task, and if the operator are monitoring, let's say, their network, their data, it's always to have good quality of experience, and also stable and services available to their customers. So the root cause analysis is, let's say, importantly, we need to anticipate any root cause, any problem to happen in the network. But actually, if it happens, we need quickly to identify what is the problem and also solve from that problem. I talked about the inventories, and this is really worldwide across operators. It's difficult to have an accurate topology information to correlate with alarms, with KPIs, and other information. The last part is that several operators started today their journey for building AI. And one of the KPI couldn't be the number of use cases. Like I'm having a forecasting model for my RAN, forecasting model for my core, forecasting model for my transport, and so what? You will be having 18 or 20 models, and then 18 and 20 pipelines to maintain. It's very costly. So the KPI should be the number of reusable, let's say, pipeline, reusable data and AI pipeline for forecasting that could be, let's say, suitable for several use cases. Of course, you would need to train for each and every model, because the data is what makes the model, let's say, available and used and used for you. But you can, for example, use feature store. You can use, let's say, optimized pipeline so that you can cover several use cases instead of having siloed data pipelines. Last but not least, it's the silos, the network. It's by design. We have the RAN, we have the core, we have the transport, and all of this are used to be, let's say, a separated organization, and so separated data, and so silos between the data. So all operators are working into bringing together the data in order to have, let's say, insights extracted to cover the end-to-end network. Okay, so now I will have 2 slides to motivate why generative AI is important for networks. So one of them, it was about the silo. When you are using traditional machine learning, of course, traditional or classical or whatever, it's really important. Machine learning that we used to do for the network, it's still very important, and Gen AI cannot solve all the problem. But here I wanted to highlight that when you are using classical ML, you will have always, let's say, a specific task to do, like forecasting, clustering, classification. So the model is trained to do one task. While when you are moving to the foundation model, it's this multimodality or this, let's say, multi-supported scenario. You will train, you will reuse, in majority of cases, a pre-trained model that it's capable of doing many tasks: information extraction, summarization, recommendation, generation of code, or also being with you in a Q&A and dialogue. So this fact that this foundation model is by design multi-scenario, that you can, of course, tune to your different scenario that you want to cover, it's helpful for optimizing your pipelines toward the smarter network. So this is one point, is that multi-scenario, it's now possible with generative AI, with at least a pre-trained model, and you can also fine-tune with respect to the specific use cases. Now the second part is about, in the network we have the design time and the runtime. So the design time is all about your specification, your topology design, your threshold, the architecture, all the, let's say, the KPI definition. Those are all Excel file or, let's say, CSVs and, for example, PDF, docs. It's anything that you have in your, let's say, intranet for the network, where you define all these design time documentation. Or, for example, you describe your 5G network and the deployment criteria and, for example, the different nodes criteria, the different vendors around it. So you'll describe everything in a document, and a lot of documents are describing all the network, but those were completely isolated from the runtime, which is, I'm collecting my telemetry, I'm collecting my alarms, I'm collecting my KPIs. It was difficult to bring those, let's say, 2 sources together. And now with Gen AI, you can definitely talk to your databases, and I will show an example on that, where you have your telemetry or tabular data in general. And on the other hand, you will have your document where it is, let's say, the next level of NLP. You can read your specification, identify the threshold, and find out if this threshold, for example, is for example, now exceeded by your some of the KPIs that you have. So you can bring the 2 words together, which is huge for the network operator. Another example is to say I'm having problems in my network incident, and those are depending on some network vendors. So I will go, my Gen AI will go and read the MOP or the description of your troubleshooting command, and then from there it will also go and execute what are the recommended commands. And I will show an example on that. So it is really bringing the 2 words together. And yeah, question?
What does MOP stand for?
Oh my God. It should be management operation or management. It's the document where you have all the troubleshooting, describe it for a given vendors. For example, for this incident, this is the troubleshooting command that you should execute. And it's a list of processes and steps that you need to do to troubleshoot from a given problem, yeah. And I forget the right abbreviation. Thank you, operating procedure. Thanks a lot. So it's not one document. It depends on the technology. It depends on the vendor. So it's really a lot of them. So bringing those 2 together, as I said, it's now possible with Gen AI. So with that, we move to the customization, because as you can imagine, the network is a lot of specific domain. You have different protocols at different levels. You have abbreviation that only understood by, let's say, network expert. If you say PRB or IRC or AC, all of this cannot be understood by a data scientist. Those are understandable by the network expert themselves. Now, if you test, for example, model like Claude 2 or Claude 3, now if you have a lot of, let's say, columns from your radio access network, so the model is capable of understanding what is PRB, what is RRC, how to calculate the congestion from, for example, identify the congestion from your network. So the model is playing the role of a network expert, understanding those abbreviations and sharing to you the insights on demand. So here you have different steps. Of course, you will not go to retrain from scratch directly. You need to have your baseline at least. You will start of course, prompt engineering, and here you will customize your model to your data and to your scenario. For example, you are extracting information from the troubleshooting document, or you are reading your specification to map to your KPI definition. The The second one is the retrieval augmented generation. It means you are giving the context, so you're connecting your model to your databases, to your knowledge base in order to read and share for you, use this as the context to respond to your queries. The second, the two other steps, let's say instruction fine-tuning and fine-tuning, here you started to modify the model, and here you, for example, you did your baseline prompt engineering and RAG, and you identified that for some queries or for some question, your model is not doing well. So you need to understand for which queries your model is not answering correctly, and for this data, you will go and fine-tune your model. It's always will be cost-effective rather than just training your model to everything. And of course, if you have very specific tasks and you need to have your telco, let's say, model, of course, you need a very big ROI for that, and you need to make sure that all the previous steps are not, let's say, enough for you. It's important to have this for your baseline, for your ROI, and you can go, of course, and go and retrain your model. Now, this slide is very high level. It's high-level design of what I call the AI continuum. And again, here I'm bringing together the different slides I was describing to you so far. So the design time, it's really all the documents, PDFs, CSV that you have in the network, and these are per technology, per vendor, and they are moving all the time. So here you will be able to have the versions read by your model, and your model keep understanding the evolution of what is happening in your network. And on the other hand, you have the real-time, near real-time, or streaming data that you are using and collecting from your data, and you can combine both because you are using GenAI and AI. So basically, this is the first source. The second one is on the bottom part, which is your AI. So you have your forecasting module, you have your anomaly detection, your clustering. Those pipelines are also source of information to GenAI, and the GenAI will play the role of building for you the knowledge. So we since 10 years, everyone is talking about the knowledge for the network, knowledge graph, the intent-driven based on the knowledge graph, and we worked a lot with Laurent previously when we were doing research. So it's possible now to create this because you have your access to the databases, but you also have the access to the knowledge, the vectorized knowledge that you put in your vector databases. And you will see some example from there. And of course, you can access this in a dialog database, but still for the network, it's not a dialogue. You will not wake up in the morning and say, do I have an incident in my network, right? It's not in a Q&A mode. You need your network to talk to you in a proactive way to say, there is a problem, this is what I detected, and this is how I want to recover it. Do you allow me to recover from this? And then the model can execute. And there will be a demo on the closed loop later on. So this is the HLD. Now I will be zooming on the first part, which is I am, let's say, on demand, asking my network about, like, for reporting, code analysis, or just to understand the health check for my network. So this is what I'm putting behind the observability. How much I'm doing about time? Good, okay. So the observability, it's a big concept. So here it's the basic one. Let's say you have your KPIs, so these are the performance indicator. You have your fault management, and you have the counters, which could be the raw data that you're collecting from the network. And all of these are tabular data, structured and tabular data. So it is useless to take this data and transforming into embedding and then query it from with the GenAI. So today there are many frameworks like LongChain, and they have agents specified for databases. You can use the SQL database one, you can use the OpenCipher one. There are many agents that you can use that talk to the database directly. So basically, this is one of the most asked use case today, and it's very easy to do with the different enablers that I'm showing in the photo here. So basically, you will have your data coming from different sources. You need, of course, there is no magic. You will not throw the data to the GenAI directly. You need to prepare the data with, for example, here, the crawler, or let's say the automated ETL to extract the schema from your data. So you need the name of the databases, you need the name of the columns, you need the name of the tables. And from there, you grab the schema in a way that the model can read it, understand it, and execute for you the query and return for you the result. This is so powerful for on-demand understanding of what is happening in the network, querying on demand rather than having a lot of dashboard everywhere. So this is for you a way to talk to your network directly, and this is very important. Very good, thank you, Laurent. So it is simply saying, talking to databases directly, grabbing the information, and to the raw data. Here, it's very important to mention this. If you are building your KPIs today, the vendors are changing their model all the time. and you go and change your formula again. And this is months of work because you have the syntax-based, let's say, KPI and dashboarding, etc. When you use GenAI, it's semantic-based. So you talk to the raw data, whether the vendors changed their data model or whatever, PRB or physical, RB, whatever, it's still the same for the model. So you don't need to update your KPI. This is also a lot of, let's say, optimize it and gain of time for you. Next to that, was announced in Mobile World Congress, so we worked with our partner MyCom OSI, and this is, for example of integration. It could be also done in any of your existing OSS. You just, for example, here you click on one of the alarms, and the model will tell you what the alarm is about, the KPI related to that, and you can continue to troubleshoot, etc. This is very helpful because we always suppose that operational team knows everything about, all the millions of alarms that are happening in the network, which is not a human-oriented task. So with that, they can just click on that, and they have the information about the alarm, the summary of what is happening. They can connect to the KPIs, and then they get help for their troubleshooting. Okay. Now, this is about the observability for tabular data, but this is not all. The next step, which is for me the obvious step, let's go back to bring the network as a graph. The network is represented by topology. It is by design and interconnected, let's say, nodes together between edges, etc. But it was always split into a lot of tabular data, and then when we started to do AI, we wanted to bring all this tabular data together, so it was very difficult. So here, why not to come back to the representation of the network as a graph, which is the normal representation. And I think I don't need to convince you that the network is a graph, but why graph for let's say, the root cause analysis, but also beyond that. It's actually for the event, let's say, insight or event network behavior and network event understanding. So first of all, you will be, let's say, taking your topology, enriching it with your time series or measurement that you are having at each of the nodes. And from there, this is, let's say, the representation. It's like a digital twin. It's like your digital representation at an instant T of your network. And you can grab the insights from that instant T, but also from the historical, let's say, snapshot of your network over time. And the graph, it's by design very simple data models. You have a node and you have an edge that is connected to it. So it is very easy, and it's meant to be scaling, and it's meant to be very big. So if you take, I've used, for example, just an example of open source data to give you a sense of magnitude here. So if you have 69K of cells and 5K of user, you will have 3 millions of connection in between. And this is very small. This is not even 1% of a normal network. But just to show you that the graph is meant to be very big. It's not, let's say, I'm going to do a graph, but it's a very small graph. So you don't need a graph, actually, if you're going for a very small representation. Now, why graph and graph for the network? It's a complex problem. It's not an easy something, and it's not an easy, let's say, like social network representation as a graph. It's because the graph for the network, it's evolving over time, because you have your time series, your alarms evolving over time. But you also have topological changes, because you have new network nodes, you have a new type of subscribers, you have new technologies coming. So the topology is changing, but also the temporal aspects are changing. So this is why the network is a graph, but it's a complex graph. And it's also a heterogeneous graph, because you can have users, you can have nodes, you can have configuration. So it's really a mixture of things that you need to put together to understand what is happening. And I was talking here about, the representation of the graph, and GNN is, the GNN family of model, graph neural network, are one of the most cited, let's say, a lot of papers on that. But it's not enough. And actually, GNN should not be the first step to resolve the problem of root cause analysis, or also to understand what is happening in your network. So basically, analytics is the, let's say, the foundational aspect that you need to do when you have a graph. And here you can see the type of model. So these are, for example, the built-in model. These are open source models that we optimized and put on AWS cloud so that we can bring insights from very big graphs. It's billions of connections that you have here. So it's not the fact that you have the model, it's actually to have the optimized infrastructure to run that model. Otherwise, it's very expensive, very slow, and you cannot even execute it. So here it's all about, for example, understanding the centrality, the similarity, and the community detection. Imagine that you have your, let's say, end-to-end core network and RAN network. It's all represented as a graph. And you want to know what is the node that is the most impactful on this, for example, in a given region or with a given configuration for a given technology. So with algorithm like centrality and community detection, you will understand and identify those nodes. And so if you have any problem happening, it's easier to say, okay, this one will impact all the others, and those are the impacted customers, and this is the region where I'm having all, let's say, the faulty or the non-respected SLA. So it's a straightforward way to understand what is happening on network before even you go to the, let's say, the machine learning or the generative AI part. And you have all the links here to see those models in details, of course, and understand what is behind that. But my main message here is to say, when you are doing root cause analysis, or when you are doing root cause analysis or event extraction from the network, it's 4 steps mainly. So the first one, you will represent what you know from your network as a graph. And of course here, you don't know everything. Maybe you missed some connections. Maybe you don't have updated inventories. It's normal. And the graph, it's meant to be easily scalable and extendable. So you represent what you know. Then you will use GNN to complement your graph. So here, for example, a task like link prediction will help you to identify the missing links in your graph. So you are complementing your topology from the one you know to the one that the model inferred some missing connection. This is the first step to have, let's say, iteratively completion of your topology. The next one is graph analytics, and here you will understand the centrality, the importance of node, the clustering of your graph, where you have, for example, the most, let's say, happening failure or the most occurring events, etc. Once you do that, then yes, the last step is also to have your GNN or your graph neural network applied into subgraphs, and with that you are, let's say, guaranteeing that you are working in a cost-effective way, and you don't apply your GNN to all the graphs because this could be very costly. So these are the 4, let's say, steps that you should consider, and this is our approach and how we are doing a graph for network today. I'm happy to share that with Orange at the Mobile World Congress, we announced that you are working together, and there will be a video soon published on about the streams that you are handling with graph and root cause analysis. Not only that, we also have, for the photo, okay, there is a photo, go ahead. Thank you. And the next one is also with T-Mobile. There was a T-Challenge. I really like this initiative. Like, it's a yearly challenge, and T-Mobile is asking for innovation and what are the approaches that we need to think about for the future of network or how to transfer the network, also other domain, the telco domain in general. So here also the approach that you proposed for the graph representation and how to extract insight is also selected among the 12 nominees. So now we have to go to the first nominee in the next 2 months. But this is a very good initiative to, let's say, cross-fertilization and how to transform the network into the right, let's say, smarter network. Now let's go to the closed loop. I have 9 minutes or 10 minutes. Yeah, okay, cool. This one will include a video so that you can see how it works. So the closed loop was my dream since I started to be a researcher and then moved to production and then moved to AWS. I was working in Orange previously. So the network closed loop, it means, I mean, if you want to forecast anomalies or you want to understand what is happening, if you are identifying root cause, it's always, you want to execute, right? You want to recover the problem, or you want to anticipate the problem from happening and, you know, having the network all the time in a very stable state. So here we exemplified the closed loop into NG Voice. This was presented at Mobile World Congress this year. This platform is the cloudified AMS, so the IP multimedia subsystem, where you can have voice, streaming, and session services, media services in general. So here we are having this up and running in the cloud, and then you are extracting in streaming mode the syslogs or the logs that are describing your session and the connectivity and all the status of your nodes and pods running in your platform. So these will go. The upper part is the on-demand observability. It means you are asking your network on what is happening. And the lower part is what is new. So here, it's proactive closed loop. It means you don't ask the network what is happening. It's your model watching your logs and identifying for you the sequence of logs that it's categorized as abnormal because you have error, because you have failure, because you have description of words related to problems and incident. And then we'll share this to you and telling you, this is my summary, this is what I recommend, and I can fix it. This is the way I hope I can fix it. And then it goes from there. So we will go to see this demo. I will skip this explanation here to go and leave some. Is this working? Yes, it is working, but I need to. Okay, so this is with our customer Telius, and NG Voice is for the IMS platform. So here, the first thing I'm doing is that I'm creating a problem between the SCSCF and the HSS to simulate a problem in the network and see what the model is doing. As you can see here, so the model is watching the logs that are coming. And at some point, the model, maybe to stop here a bit, selected for you the 2 logs that are indicating a problem in the network, which is about the connectivity between the SCSCF and the HSS. So the model selected those among millions of logs happening in a second level here from the NG Voice, and then bring for you the explanation, and then bring for you what to do to recover from this. So this is, you are in a proactive way, the model talking to you and telling you this is what is happening and this is how we can recover. Now, if we continue the demo, so here I wanted to make sure, because the closed loop, it's also important to have the human in the loop. The human will be assisted by the GenAI, but it will not be replaced by the GenAI. It depends on the strategy, it depends on the size, it depends also on the events that are happening in the network. So here I will be asking, for example, what is the status of the nodes, just to make sure that the model is that the model is telling it's correct. So here you will see that I'm having the names, the node IDs, and the types of what is running in my NG Voice. And then I will be asking about the peer connection. So here it will show me what are the different peer in my IMS that are connected. And when I will see the answer, I will see that there is no link or connectivity between the SCSCF and the HSS. It means this is confirmed by the model that it's missing. And when it goes back, you will see that there is all of them, but there is no HSS connectivity there. Yes, perfect. Thank you, Laurent. And then now I will say, okay, fix the problem. So now I confirm that the problem is right, and the model spotted well the errors and the explanation and what to do. So now I'll ask the model, fix the issue. Everything here, the model is talking directly to the NG Voice platform. It's talking to your pods directly. It's extracting through the API the information with the agent part. So here you have the model executed that. So now I want to see if this was executed. And I will ask about, again, the list of peer connection, and I will see that the HSS now appeared in the connection because it was reestablished by the agent that AWS Bedrock encompassing through the model to share the execution to the platform. And here you will see the HSS is now back because the model was able to fix this and to have it done. So here, let me stop a bit. There is no magic. The model is reading the spec of NG Voice. So the NG Voice is mentioning this command somewhere. The model role and the value add is that the model spotted right the errors that are happening from millions of logs and identify the right command for you instead of you reading and calling someone to find the right one, and also using the API to go and execute. So this is in a couple of, let's say, less than 1 minute here, because I'm putting the human in the loop. The model can go and fix the problem for you.
This is real time?
Yes, this is real time. This is streaming, yes. This is streaming, yeah. It's every second, and so the logs are coming to the model.
So in terms of latency, did you have to do something to get such slow latency between executing the command, having the LLM?
That's a very good question. Here it depends on the infrastructure, on the LLM itself. Those are the things that you can play on. But let me take this question as first one in the question part. So here, the model, you will see that it was fixed. Now I was moving to the observability. This is another mode. The first one is the model talking to you, and the second one, you are asking the model. So both are available, but the second one is the most one that you need to have. And I will not I will show the first query, and then I will stop there. Here the model is querying a database that is refreshed each 2 minutes and grabbing for you the information. And then you will have the model is sharing for you what is happening about your SIP session, the SQL that the model executed for you to verify, and you can also add explanation and a lot of other stuff. Okay, I'll stop here, and then, yes, thank you.